Electric cars are reshaping the automotive world, becoming more mainstream by the day. In a world where environmental concerns, rising fuel prices, and technological advancements are rapidly changing the landscape, electric vehicles, EVs, stand at the forefront of the future of transportation. But what exactly makes electric cars tick? What are their benefits and challenges? And why are they gaining so much attention? In this video, we'll dive deep into the mechanics of electric vehicles, explore the differences between EVs and traditional gas-powered cars, and discuss how they are revolutionizing the driving experience. Let's get started. What is an electric car? At its most basic level, an electric car is a vehicle that runs entirely on electricity. Unlike traditional internal combustion engine, IC, vehicles that rely on gasoline or diesel to generate power, electric cars use an electric motor powered by energy stored in batteries. The electricity is stored in large battery packs, and this energy is used to power the motor and move the car. How do electric cars work? Understanding how an electric car works involves looking at a few key components. Battery pack. The battery pack is the heart of an electric car. It stores all the electricity the car needs to run. These battery packs are typically made from lithium-ion cells, which are known for their high energy density and relatively long life. The larger the battery pack, the further the car can travel before needing to recharge. On average, electric cars can travel between 150 and 370 miles on a single charge, depending on the model and the size of the battery. Electric motor. The electric motor converts the electrical energy from the battery into mechanical energy that moves the car. Electric motors are much simpler than gasoline engines because they don't require a complex system of belts, gears, or fuel injectors. Instead, they use magnets and electricity to create movement. This means electric motors are more efficient and provide instant torque, giving electric cars quick acceleration. Regenerative braking. One of the most innovative features of electric cars is regenerative braking. When you apply the brakes in an electric car, the motor switches to reverse, acting as a generator that converts some of the vehicle's kinetic energy into electrical energy, which is then sent back to the battery. This helps extend the car's range and reduces the wear on brake components. Charging. Electric cars are charged through an external power source. The most common types of charging stations include Level 1, regular home outlets, Level 2, 240V stations, and Level 3, DC fast chargers. Types of electric cars. Electric vehicles come in different forms, each suited to various needs and preferences. Here's a breakdown of the different types of electric cars you'll encounter. Battery electric vehicles, BEVs. BEVs are fully electric cars that run only on electricity. They have no internal combustion engine, no gas tank, and they can't run on anything other than electricity. These are the most common types of electric vehicles today. Some popular models include the Tesla Model 3, Nissan Leaf, and Chevrolet Bolt. BEVs require frequent charging, but with proper infrastructure, they can be used as daily drivers. Plug-in hybrid electric vehicles, PHEVs. PHEVs combine an electric motor with a traditional gasoline engine. The electric motor is used for shorter trips, and once the battery is depleted, the gasoline engine takes over, providing more range. This hybrid system allows drivers to switch between electricity and gasoline depending on their needs, making these vehicles more versatile. Examples of PHEVs include the Toyota Prius Prime and the Chevrolet Volt. Hybrid electric vehicles, HEVs. Unlike PHEVs, HEVs cannot be plugged in to recharge. Instead, They rely on the gasoline engine to charge the battery through regenerative braking and the internal combustion engine. HEVs have smaller batteries than FEVs and can only travel short distances on electric power alone. Popular HEVs include the Toyota Prius and the Honda Insight. Fuel cell electric vehicles, FCEVs. FCEVs are powered by hydrogen, not electricity, but they are still considered electric vehicles. They use a fuel cell to combine hydrogen with oxygen to produce electricity, which then powers the electric motor. While FCEVs offer the same benefits as battery electric vehicles, such as zero emissions and quiet operation, they are less common due to the limited infrastructure for hydrogen fueling stations. Charging electric cars. Charging is one of the biggest concerns for potential EV owners. But as the world moves toward electric mobility, charging infrastructure is improving at a rapid pace. There are three main levels of charging for electric vehicles. Level 1 charging, 120 EV. This is the most basic form of charging, using a standard home outlet. It's the slowest option, providing around 3 to 5 miles of range per hour of charging. While this is sufficient for overnight charging at home, it's not practical for long trips. Level 2 charging, 240 VAR. Level 2 charging stations are commonly found in homes, workplaces, and public charging stations. These chargers are significantly faster, offering between 15 to 30 miles of range per hour of charging. A full charge typically takes between 4 to 8 hours, depending on the car and battery size. Level 3 charging, DC fast charging. Level 3 chargers, or DC fast chargers, are the fastest option available. These stations are typically located along highways and in public areas. They can charge most EVs to 80% capacity in about 30 minutes, making them ideal for long-distance trips. However, they are more expensive to install and not as widespread as Level 2 chargers. As electric vehicle adoption grows, more charging stations are being built around the world. Companies like Tesla have their own network of supercharger stations, while other providers like ChargePoint and Electrify America are building large networks to cater to various brands of electric cars. Benefits of electric cars. The shift toward electric vehicles comes with numerous benefits, from environmental to economic advantages. Environmental impact. One of the most significant benefits of electric cars is their positive impact on the environment. EVs produce zero tailpipe emissions, meaning no harmful pollutants are released into the air. This makes them an essential tool in the fight against air pollution and climate change. Additionally, as the energy grid becomes cleaner with renewable sources like wind and solar, the carbon footprint of EVs continues to decrease. Lower operating costs. EVs are significantly cheaper to maintain and operate compared to gasoline-powered cars. Electricity is cheaper than gasoline, so owners spend less on fuel. Electric cars also require less maintenance since they have fewer moving parts, eliminating the need for oil changes, fuel filter replacements, and exhaust system repairs. The brake system lasts longer due to regenerative braking, reducing brake wear. Energy efficiency. Electric vehicles are more energy efficient than gasoline-powered cars. Electric motors are inherently more efficient at converting energy into motion compared to internal combustion engines, which waste a significant portion of energy in the form of heat. This means that EVs can go farther on the same amount of energy, reducing overall energy consumption. Quiet and smooth ride. Electric motors are almost silent, providing a smooth and quiet ride. Without the loud hum of an engine, electric cars offer a more relaxed and enjoyable driving experience, especially in urban environments. The future of electric cars. As we look to the future, electric cars are poised to become even more advanced. Here are a few trends that will shape the future of EVs. Battery technology advancements. Battery technology continues to improve, with new breakthroughs in energy density, charging speed, and cost. Companies are developing solid-state batteries, which promise to be lighter, longer-lasting, and safer than current lithium-ion batteries. Autonomous driving. Many electric cars are already equipped with semi-autonomous features, such as Tesla's Autopilot. In the coming years, we may see full self-driving electric cars become mainstream, providing an entirely new experience for drivers and passengers. Global EV adoption. Governments around the world are pushing for cleaner transportation options, offering incentives and subsidies for EV purchases. As more charging stations are built and EV technology becomes more affordable, the adoption of electric vehicles will continue to rise. If you've enjoyed learning about electric cars and want to stay updated on the latest in automotive technology, be sure to subscribe to TechEase. Hit the bell icon to get notifications whenever we upload new content on electric vehicles, tech trends, and much more. Electric cars are no longer a futuristic dream. They are here, and they are changing the way we drive. With their eco-friendly benefits, lower operating costs, and the ongoing advancements in technology, it's clear that electric vehicles are the future of transportation. As charging infrastructure continues to grow, and as battery technology improves, electric cars will become even more accessible and practical for everyone.